A message was detected from deep space. It wasn't a star. In the vast silence of space, Earth is constantly listening. Radio telescopes stretch their metal arms across deserts and mountaintops, tuned to the faintest frequencies the universe emits. Most of what we detect, cosmic noise, pulsars, distant quasars, is predictable, mapped, understood. But then, something unusual happened. A burst of energy came from deep space, brief, intense, and completely unlike a star. It wasn't a natural stellar flare, a black hole, or a supernova echo. It was something else. And it repeated. In this video, we explore one of the greatest modern mysteries of astronomy, a strange signal from beyond our galaxy, and the haunting possibility that we may not be alone. The signal that changed everything. What happened? In 2007, while analyzing old telescope data from Australia's Parkes Observatory, astronomers stumbled upon something unexpected. A millisecond-long burst of radio waves from far beyond our galaxy. It was extraordinarily powerful, releasing as much energy in a single moment as our sun does in a day. They called it a fast radio burst, an FRB. At first, it was dismissed as a fluke, perhaps interference, but then more were found. Dozens, then hundreds. Some came only once, but then one signal changed everything. It repeated. In 2016, astronomers detected multiple FRBs from the same location, 3 billion light years away. It wasn't random. It had a pattern. And that's when scientists and skeptics alike started whispering a once taboo word, artificial. Natural explanations, and why they don't always fit. The first instinct of any scientist is to explain the unknown using natural laws. FRBs were initially attributed to collapsing neutron stars, magnetars, ultramagnetic stellar corpses, or the merging of black holes. These are real, violent cosmic events. They can produce intense energy spikes. But there's a problem. Most FRBs appear random and non-repeating, which fits catastrophic events, but some repeat regularly. One in particular, known as FRB 180916, repeats every 16.35 days, like clockwork, on schedule. This kind of consistency doesn't align with destructive cosmic events. Even stranger, some FRBs seem to come from quiet, non-active regions of space, places with no stars, no black holes, no galaxies nearby. So what's creating them? The deeper scientists look, the more the data refuses to behave naturally. The artificial possibility. Could it be technology? If something doesn't look like a natural process, could it be intentional? This question was publicly entertained by respected scientists at Harvard, MIT, and the SETI Institute. Their idea, if an intelligent civilization wanted to communicate or power something using directed energy, it might emit powerful, brief radio bursts. In 2017, a paper published in the astrophysical journal Letters speculated that FRBs could be beamed energy used to power light sails, essentially interstellar spacecraft driven by radiation pressure. The energy levels would need to be immense, but the math checks out. If a civilization were type 2 or 3 on the Kardashev scale, they could do it. It's not confirmation, but it's no longer considered pure science fiction. For FRB 121102, the repeater that refused to be ignored. Among all the fast radio bursts discovered, one stands out. FRB 121102, first detected in 2012, it has since produced hundreds of bursts, all from the exact same point in space. It's located in a dwarf galaxy 3 billion light years away. What's unsettling is the signal's complexity. Some bursts vary in strength and speed. Others show strange polarization, twisting as they travel through magnetic fields, suggesting a highly energetic environment nearby. But no black hole or magnetar has been confirmed in that location. Scientists have set up continuous monitoring, and the bursts keep coming, some in clusters, some in silence. It behaves more like a transmission schedule than a random astrophysical event. SETI and the legacy of the WOW signal before FRBs, there was another mystery. The WOW signal. In 1977, a researcher at Ohio State University's Big Ear radio telescope recorded a 72-second burst of radio waves. It was narrowband, intense, and came from no known source. He circled it on the printout and wrote, "WOW." It was never repeated. The WOW signal became a legendary case in SETI, the search for extraterrestrial intelligence. But like most mysterious signals, it faded into obscurity. Then FRBs arrived, and unlike WOW, some repeated. SETI researchers began hoping again. If one signal could repeat, it might carry information. But decoding such signals, without knowing the language, timing, or method, remains an almost impossible challenge. Could it be a beacon or a side effect? Let's assume for a moment that FRBs are artificial. What could they be? Possibility 1, a beacon. A civilization might want to say, "We exist." A brief, repeating signal is efficient, scalable, and attention-grabbing. Possibility 2, a technological byproduct. Just as we leak radio waves from satellites, TVs, and radar, an advanced species might emit bursts while powering stellar-scale tech without realizing others are listening. Possibility 3, a navigation system. Repeating FRBs could function like galactic lighthouses, used by spacecraft to triangulate their location in deep space. We can't know, but their structure, repetition, and precision push them into uncomfortable territory. The role of China's FAST telescope. In the mountains of Guizhou province, China built the 500-meter aperture spherical telescope, FAST, the world's largest single-dish radio telescope. And its focus? Among other things, FRBs. FAST has already detected dozens of new signals, some from known repeaters, some brand new. Its unmatched sensitivity allows scientists to study micropatterns inside bursts, possible signatures of structure or modulation. China has even launched artificial intelligence initiatives to analyze signal complexity. Algorithms trained to detect non-random elements in deep space radio waves. If FRBs are a puzzle, FAST may be the tool that finally starts connecting the pieces. Could we send a message back? Should we? If we accept the possibility of an artificial origin, the next question becomes, do we respond? It's a controversial idea. Stephen Hawking once warned against active SETI, transmitting messages into space, fearing it might attract hostile attention. Others argue the cosmic silence suggests civilizations stay quiet for a reason. Yet some groups like METI, Messaging Extraterrestrial Intelligence, have already begun broadcasting signals toward nearby stars. But responding to an FRB is harder. We don't know the original format. We don't know what part is message, if any. And most importantly, even if we could send a reply, it might take billions of years to be heard. What if it's not aliens, but something we've never imagined? Here's a third option. FRBs are neither natural nor intelligent, but something else entirely. A form of cosmic intelligence we don't recognize. A quantum phenomenon we don't yet understand. A glitch in space-time, a dimensional overlap, a feature of the universe as yet undescribed by physics. After all, every breakthrough in science begins with an anomaly. Galileo's moons, Newton's falling apple, Einstein's photoelectric effect. What if FRBs are the next anomaly, inviting us to discover a new law of nature? Sometimes science fiction isn't fiction, it's prophecy, the future of cosmic listening. New telescopes are coming online. The Square Kilometer Array will be the largest radio telescope array ever built, capable of detecting fast radio bursts across half the universe. NASA's Deep Space Network is being upgraded to scan frequencies never studied before. Machine learning, quantum computing, and AI will soon be part of every skyscan. The more we listen, the more we'll hear. And the more we hear, the more we'll question. Are we alone? Or have we always been surrounded by signals too strange to recognize? Maybe the message isn't coming. Maybe it's already here. A signal came from deep space. It was powerful, brief, and inexplicable. It wasn't a star. It wasn't a galaxy. It wasn't noise. It might be natural. It might be a machine. It might be something beyond anything we've imagined. But one thing is certain, the universe spoke. And now, we're listening harder than ever before. If you found this journey into the unknown fascinating, like, share, and subscribe for more content that blurs the line between science and mystery. Because the next strange signal, it could arrive any second now.